the very quick healing of the coast, what we can call it the cicatrization of the coast. For example, here in Sumatra, 2004. So this picture was taken in 2005, a few months later by the United States Geological Survey. And you can see that a sandy bar is very quickly relocalized on the coast, on the former shoreline before the tsunami development. So there is a quick recovery from place to place of the shoreline mobility or stability. Here, another example with, you can see the forest of the palm tree and the tropical tree that was totally destroyed by the waves, but you can see the beach recovery quite quickly. So what is the question of tsunami, of paleo-tsunami in the archaeological record? What is it? Is it a fact or is it a factoid? What is a factoid? A factoid, it's like a fact, but it's a fake. So everybody knows now what is a fake news. There is no need to explain what is it. I think most of the problem dealing with hypothetical paleo-tsunami implicated in archaeological correlation are in close connection with the question of the causality or correlation. And causality and correlation are not the same. And nowadays, in archaeoscience, in geoscience, since half a century, numbers have replaced words. And we are dealing mainly with statistical correlation. So for example, let's have a look on this funny image comparing the divorce rate in Maine and the per capita consumption of margarine. For sure, we have a high correlation. We have a similar evolution in the time in the last 10 years between 2000 and 2010. But there is absolutely, as you can imagine, no causality between divorce and margarine consumption. So it's a little bit the same with the tsunami interpretation. I will develop this point on 3 PhD that I have directed in the last years, 20 years, in Alexandria Harbor in Egypt, in Tipaza Harbor in Algeria with Said Maouche, and in Constantinople, present-day Istanbul in Turkey. So let's begin by Alexandria on the western margin of the Nile Delta. It's not on the Nile Delta, but it's really at the interface between Pleistocene, sandstone, Ramleh coasts and the Holocene deltaic coast. And the submerged archaeological landscape offshore the Hellenistic Lighthouse of Alexandria is composed of thousands of meso and mega blocks that are in imbrication and that suggest a high energy coasts that are not in situ, that have been reworked by the waves, the swell impact, the possible tsunami impact, because there is a catalog of tsunami, historical catalog of tsunami in Alexandria. But for example, with this big stone, which is interpreted by Jean-Yves Empereur, the former director of the Centre d'Etudes Alexandrines, this is the granitic lintel of the Lighthouse of Alexandria. So this granitic lintel is absolutely big mega blocks, but it's impossible to date it because it's post-Hellenistic. It's impossible to see what was the exact location of this block that has been stolen by the Ptolemy in Hierapolis. And so it's an important, fascinating underwater elements, but with not a lot of scientific interests. But Jean-Yves Empereur asked us to focus on the tsunami's impact on the ancient harbor of Alexandria, especially a tsunami that is very well known. It's a tsunami well dated by the archives of 365 AD. So it is called global tsunami in the Eastern Mediterranean Sea. So we have been able to core about more than 12, 13 cores in the Eastern Harbor and the Western Harbor in the scope of the PhD of Jean-Philippe Guarin. And I will present you a core that has been well studied with Michel Boursier from Station Marine d'Andoum. Core 1 is located in the garden of the French consulate, of the former French consulate. Dealing with the Eastern Harbor, this is a map produced by the archaeological team of Gaudiot, and you can see an underwater organization of the Hellenistic and Roman harbor by Rhea, because the Eastern Harbor was too big, so the Eastern Harbor was divided at least in 4 or 5 small harbor, probably in connection with different function. You have on the left side with the white dots, the paleo island of Pharos, where was located the famous Lighthouse. You have the Eolionite Pleistocene sandstone ridge on the lower part on the right, and the white bar corresponds to the bridge and what is called by the Greeks when Alexander founded the Hellenistic city of Alexandria, the heptastadium, because it's 7 stadium of long, connecting the Pharos island to Africa. So core 1 is 14 meters depth. It is composed of, let's say, 3 units from base to top. At the base, you have in purple, if you look at the sedimentary texture, you have in purple more than 80% of silt and clay, corresponding to an artificial protected Roman and late Roman environment, so harbor setting. In blue and red, you have a very coarse, maybe you see my arrow, you have a very coarse elements of mixing material. Some are a lot of artifacts, ceramics, rounded ceramics, broken ceramics, pebbles, shells, reworked coral, cladocora branches. And as you can see, there is a big problem of chronology between 4,000 years BP and 6th century AD. So there is a lot of discrepancies and sandwich reversed C14 and archaeological determination. And in yellow, a 3rd unit of sand, which is very close to the present day sandy beach, very polluted sandy beach of the present day Eastern Harbor. So very sharp differences in texture, which can reflect different types of opening and protection from the open shore. We have, with Michel Boursier, we have analyzed very precisely the malacological content of these of the sediments contained in this core, and you can see that there is 3 colors. In blue at the base, you have what we call, from the work of the biologist of the Marine Station of Marseille, organic matter and muddy shells, also in connection with well-calibrated shells. So it's a well-protected environment. It's the harbor, the late Roman harbor. In light blue on the top, you have something which is characterized by a more open environment from a biological content, from the biocenosis. It's what we call fine sand of upper level. So it's the upper part of the infratidal zone with some impact of rocky coast in connection with the island of Pharos, and some fresh water input because we are close to the sea. And in red, you have this third unit, which is characterized by a lot of reworked spaces from all the different biotope. So a mix of everything, which is very characteristic of a high energy input. I cannot say it's stormy or it's in connection with tsunami. This is impossible, but we can say it was very, very high energy. We try to work on the exoscopic of the quartz because we have been also involved of the collapse of dam like Vaillon in Italy, the collapse of Malpasset in France, and here these are the quartz from Alexandria. But you can see with the MEB, with the SEM, you can see some very energetic and very fresh conchoidal fractures that can be connected to fracture like on the base here, on fracture of quartz. So what can we say dealing with the one core from Alexandria, but the other core showed a quite similar signal? That first of all, we didn't find the famous 365 tsunami, which is well recorded by historical archive, because there is some description like by Amiens Marcelin. So this is the first point. The second point is that we have a high energy input from the 9th century AD, which can correspond to the collapse of the harbor by about of the Roman harbor, the late Roman harbor, the collapse by about 5 to 6 meters below present sea level. So we have been able to reconstruct the paleoevolution of these geomorphological sites with a pre-tombolo, which was used by Alexander the Great to build in black his Eta Stadium during the 3rd century BC, and the accretion and the enlargement and the artificialization of the tombolo between Faroes Island and Africa during more than 1 millennia, between the 3rd century BC and 7th, 8th century AD, so between, let's say, 1 millennia and a half, and between 7th and 10th century AD, the collapse of the tombolo, and maybe the coarse unit that I showed you previously is the sedimentary impact of this collapse of the 7 to 10, between 7, it is not well dated, it's not precise, 7 to 9th century AD. So in a way, we disappointed the archaeological team of Alexandria because we have not been able to put into correlation the stratigraphic record with the catalogs of earthquake. But we were not the only one. For example, the team of Stanley from the Smithsonian faced the same problem of the absence of record. But maybe the first conclusion I can give concerning this first case study, that the absence of proof is not a proof of absence. Let's move to the second case study, Tipaza in Algeria. It's a Punic foundation from the 5th century BC. And with Saïd Maouche from Alger, from CREAG, the Center of Geophysics Research, we have worked on this coast for his PhD. And these are beautiful images of Tipaza, which is absolutely a beautiful place. You can see on the back the Chenois mountain, the basement rock unit, and very nice Roman to late Roman ruins. You can see